Welcome. So here's a math problem for you. I have 9 cards. So let me just pick a color. I have 9 cards which are numbered 1 through 9. Okay, 9 cards where I have just numbered them from 1 to 9. Now I'm going to create or distribute them in 3 groups. So I have group 1, I have group 2, I have group 3. Okay, I want to distribute them. Now, there are obviously many different ways of doing this. But what I want to do is to ensure that the sum of the 3 cards that's in group 1 is equal to the sum of the 3 cards in group 2, which is equal to the sum of the 3 cards in group 3. And the question is, how many different ways can I do this in? Okay, you can pause the video here, take your time and try to solve the problem. It's not very difficult, but it's definitely non-routine. So pause, give it a shot. All right, I hope you tried it out. If not, let's try and understand how to solve this. Okay, there are many ways to solve it because, as I said, it's a non-routine problem. So what is this non-routine problem? A routine problem is something where you probably have a formula. So you just look at the problem, you think of which formula to plug in the values, and appropriately get the answer. That's a routine problem. A non-routine problem is where there's a certain amount of experimentation that's involved, an experimentation of trying out different things, looking at just the way you do a scientific experiment, you do a mathematical experiment. For example, in this case, I would say, what if I bring in 1 into group 1? So I put 1 here. What happens then? What are the other numbers that's possible? Right? So this could be an experimentation. This could be a way of trying this out. So if I were to experiment kind of randomly, there's probably like close to about 72 different ways of selecting 3 numbers to go into group 1. That's a lot of experimentation. Right? And this is where mathematical thinking will help you reduce the scope of this experimentation to make it very simple with certain logical and commonsensical ideas. So for instance, let's take a step back and think about all of these cards. We know that there are 9 cards and eventually they need to sum up, together. So if I sum up all of this 1 to 9, I know that I get 45. Right? So I have 45. The sum of the numbers from 1 to 9 is 45, which means I can basically conclude that each and every heap, each and every group needs to have 15. So if I put in 1 here, the remaining 2 numbers need to add up to be 15. Right? So I can think of putting in 9 and 5. This is one way of looking at it. Right? And of course, I need to put an 8 somewhere, so I can add 8 here. And if I have 8, the remaining 2 numbers need to add up to 7. So it can't be 7, it can't be 6 because 1 is already used. So it's got to be what? Maybe 3 and 4. And let's come back to that. And let's think of the third one, which, if I know that 9 and 8 is here, I know that 7 is here. So I can think of maybe 6 and 2. And here it's 8, 3 and 4. So this is one way of doing it. But is this the only way of doing it? Let's try another combination. Let's think of it as maybe instead of 1, I could start with 2 and use 9. So I have 2, 9, and what about the third number? The third number needs to be 4. So which means I know that it has to be 8, 1, and 6. Therefore, leaving 3, 5, and 7. So these are 2 different ways in which I'm able to come up with this heap of 15 so that the groups are equal. Are there more number of ways? If you think so, why don't you share your thoughts in the comment section? I hope you found this problem interesting. The idea here is not to just find the solution, but actually spend your time understanding the algorithm, understanding the process of how one arrives at the solution. For more such videos, please ensure you like this video, subscribe, and click on the bell icon so that I can come back to you with more such interesting non-routine math problems. Thank you so much.